This video is for Chapter 2.2, Part 2 lecture. We're looking at histograms. And so we left off looking at these histograms and kind of interpreting what they were and what the heights of the bar graphs mean, frequency and relative frequency, and the names of these bins or the bars we call classes. They're the categories that build the bars. So that's where we left off. And so this is where we are. You should have your note sheets out. And so we're looking at right here. So we have some terms we're going to be looking at that go along with the histogram. So the first one is what's called the lower class limit. And again, what that is, and you can get that from the PowerPoint or from my writing here, lower class limit of a class is the smallest value. That's important right there. It's the smallest value. Comparing that to what's called the upper class value, or upper class limit, sorry, and it's the largest value within the class. And so in this case, you can see the lower class limit for this one here. These are 4 classes. The lower class limit is 25, and the upper is 34. And then you have something called the class width. Oops. The class width, how wide each of those bars is. And the way you get that is by subtracting the lower class limits. And you can see it's 25 right there, or 10 right there. When we did 35 minus 25 right there, you get 10. And so here's an example of data that's been summarized in a table and then can be converted into a histogram. These are the classes, and these are the frequencies of that. So let's go on to another example here. Construct a frequency and relative frequency histogram for these values. These are just sample percentage rates that you would get if you invest your money for different banks. And so what would we look? What story would be told? You can see different numbers now, but because it's organized and it's not organized in a table of values or a frequency distribution or a histogram, it's hard to kind of tell what story is happening here. And so in this case, let's take a look. Let's actually construct this. And the way we are going to do that again is through StatCrunch. So I want to make sure I have that data entered in right here. Move myself over here. The data entered right here. And on StatCrunch, what you're going to do is a graph histogram. And so that data is in already. You have to put that in histogram. And then the variable is 5-year return. So we put that in there. And we're creating a histogram. And that's all we got to do. It's going to do all the work for us here. You can pick the type you want, a frequency or relative frequency. We need to do both in this case, but this is what we got. And so you can see here is the histogram for that set of data. I can tell already it's skewed. Look like there's some skewed right. And then now that's a frequency histogram. We can go ahead and do the same thing, histogram, same data, and then we would want to create a relative frequency. That's what the example is asking for. And so then we get this relative frequency. As you can see here, the distributions are same. The only difference is we have you have the actual frequency versus the decimal value, like 40%, 30%, 20, and so that's the difference there. And so as you can see, as I put this in from StatCrunch, which is what we're going to use to make the histograms, you can see the distributions are both skewed right. And when I mean skewed right, you can see the tail like that right there on the sides, right? Those are the tails skewed to the right. And so there's our construction. Now in this case, if you look carefully, if you wanted to make note of something, you can see there's classes here from 0 to 4, or sorry, yeah, 0 to, from 2 to 4. I don't know, what are these? They're going by ones, actually 4 to 5, 5 to 6, 6 to 7, 7 to 8. You can see that's it. The class widths would be 1 in this case. And so that's what we look at. Think about this question real quick. What happens to the number of classes as the bin widths increase? So imagine if we increase the bin width and made the widths wider. What happens to the number of classes? If you make your bin widths bigger, if you make the bin widths bigger, what has to happen is then that the number of classes would decrease because you have less, your bin widths are getting bigger, which means the number of classes decreases because you're making the bar bigger. So if you went from 6 to 8, that would give you 1 class versus 2 classes, right? So when the bin width is 1, you have 2 classes here. But if the bin width was 2, then you'd only end up with one class there. So that's the idea there that we have for histogram in classes. The next thing, let's end there and we'll go to one more video after that.